teach them how to respond to any phrase you might say. So instead, these AIs use that stored information to identify keywords in context so that they can hopefully guess what you want. And as for Nadine's soft, sensitive skin, which actually lets the robot respond to touch, the scientists at NTU haven't released the technical specs yet, but we do know how most artificial skin works in cutting-edge robotics. Generally, a film of thin, super flexible rubber is placed between two sheets of parallel electrodes. Each individual electrode has a partner on the other side of that film of rubber, and a small charge is generated by each pair of electrodes, which is stored by the rubber between them. When you touch this artificial skin, it's compressed, meaning that the rubber thins and is able to store less electric charge. Information on how much charge there is between each pair of electrodes is fed to a program that creates a topographical map of where and how the skin's being touched. Then the robot's AI decides what to do with that information. So Nadine is an incredible fusion of different disciplines: AI, robotics, computing, pressure-sensitive electronic skin. So what makes it so creepy? If Nadine gives you the heebie-jeebies, you're experiencing something called the Uncanny Valley. The Uncanny Valley is based on the idea that the more human-like and less machine-like something seems, the easier it is for humans to respond to it emotionally. Except when something looks almost lifelike, but is off by just a tiny bit. That makes our emotional response go way down. Our brains just think it's creepy. That's because when an artificial human looks just human enough, all we can focus on is where the illusion is falling short. It makes our parietal cortex light up. The parietal cortex connects the brain's visual processing center with the motor cortex. When you look at what your brain thinks is a person, it mirrors what you're seeing onto your own muscular